All right, let's talk about acids and bases. You've done this in earlier classes, but just a quick review. Um, Acids taste sour. They feel like water on the skin, unless you're going to talk about sulfuric acid. Whoa. It feels a little oily. They're caustic and corrosive. I guess that's not really what I want to do here. It's caustic and corrosive. Caustic means it will destroy plant and animal tissue, and corrosive means it will attack metals. So acids do both. They conduct electricity very well if it's a strong acid, and we'll talk about what a strong acid is in a moment. Weak acids, they do all right at conducting electricity. They turn blue litmus paper red, and they change lots of different indicators, different colors. And in terms of pH, they're going to have a pH less than 7. Base properties, they taste bitter. If you ever got soap in your mouth, you know they taste bitter. They're slippery on the skin like soap, and that is because they are caustic, and they turn oil on your skin into a soapy solution, and that's why they feel slippery. They're also excellent conductors of electricity. Weak bases are mediocre. They turn red litmus paper blue, and they'll change all sorts of other indicators, different colors at different pHs, and they usually have a pH greater than 7. All right, two really important words here. Concentrated and dilute. Let's start with those. Very misused. Concentrated is talking about how much stuff I'm putting in my beaker. So I got my water here, and I got this big chunk of stuff, and I'm dropping it in. That would be a concentrated solution. If I take a very small amount and I put that in instead, that would be a very dilute solution. Yes, it's talking about how much solvent you're putting in. So 16 moles in a liter of HCl would be more concentrated than only half a mole per liter. Strong and weak are two totally different terms. They refer to the ability of an acid or base to dissociate. So, for example, and we're going to talk about it down there, but anytime something is put into water and breaks up into its ions, we say that it is dissociating right here, dissociate. And strong acids completely dissociate. When I throw HCl into water, there is no HCl left. It is gone. All I will have is Cl minuses and H3O pluses. If a weak acid or base, only a little bit will dissolve. Maybe as much as 10% will dissolve, but not 100%. Strong and weak bases. So we've got just what I talked about here. If it highly dissociates, we call it a strong base. The big ones are NaOH, KOH, RBOH, yes, CaOH2, BaOH2, all strong bases. And again, it's a strong base, so when NaOH hits the water, there's not going to be any NaOH left. It is gone, gone, gone. I will have NAs, and I will have OHs. Okay? Here it is here, completely ionized into those. Other bases, other than these ones listed here, we usually consider them to be weak, and they are not 100% broken up into ions and placed into water. Okay? Weak acids. Okay, HCl is a strong acid. Okay? H2SO4, strong acid. Nitric acid, HNO3, strong. What are some weak acids? They, again, looking at the term weak right here, weak means they will not completely break apart, like acetic acid. Acetic acid is a weak acid. It's an organic acid. Most organic acids are weak, like almost all of them. When I throw acetic acid into water, some of it will break up, some of it will not. Right? And often when you have a weak acid or a weak base solution, you know what this is, you get an equilibrium set up. Okay? And so we'll get some of this turning into that, some of that turning into that, and the concentrations will be fairly constant. Okay? And here again, just to reiterate that point, weak acids have a very low degree of dissociation. Yes. HCl is 100%, yes. Acetic acid, look, 1.3%. Not even 2 out of every 100 molecules will break apart. And so these are just some key terms. Again, weak, strong, concentrated, dilute, that you need to know moving forward.